ohmic conductors. So I'm just going to come and find, there we go, nice and easy, our equations here to do with, firstly, resistance. Let's ignore that for now. We're asked to calculate the resistance of our conductor, and we're told some of the dimensions and the resistivity. Okay, we are told the length here, and then the surface area, essentially. Okay, so we're going to use our equation rho equal to RA over L. In other words, R equal to rho L over A. Okay, we're going to use that. And we're going to substitute our values in 1.7 times 10 to the minus 8. That's just our resistivity. Okay, 0.1, that's our length. But we've got to remember to change our 10 centimeters into meters there. Okay, and then our area. Well, if you remember here, if this is our length coming across here, then this shaded part here, okay, is going to be our area. In other words, it's going to be the two small dimensions, W times H. Okay, and we're going to multiply those together and express them in form of meters squared, so SI form. All right, that ends up being 4 times 10 to the minus 8, because we've got 4 times 10 to the minus 4 centimeters squared. Meter squared is going to be even smaller. And we end up with a resistance there of 0.043 ohms. So the key point here being you need to make sure you're changing these units from centimeters into meters. Somewhat frustratingly, the question then says to you, calculate the drift speed in centimeters per second. So all that nice work that we've done converting into meters is kind of irrelevant here. All right. For this, we're going to use our equation NAVQ. Okay, it's written over here. We are being asked to calculate V. Okay, so we don't know V. We know Q because it's an electron, and therefore charge is going to be equal to E, which is 1.6 times 10 to the minus 19. In your data booklet right up at the front here, okay, charge is E, 1.6 times 10 to the minus 19. You are not expected to remember that. Just scroll back. We know our density of free electrons, that's N, okay, sometimes called charge density, and it's expressed in centimeter per centimeter cubed. So we don't need to worry about changing anything here on our N, we simply just need to think about the other quantities. Well, the bit that's going to be the troublesome bit is A. Well, A is written in centimeters, so what I would suggest there too is using our centimeter squared version, 4 times 10 to the minus 2, and then it is simply a case of putting in our current value, 2, into the equation, dividing, and then getting an answer of 0.367 centimeters per second. Now, always worthwhile to state your answer to an appropriate number of significant figures. Well, what is appropriate here? Notice here, 2 significant figures, 2 significant figures, 2 significant figures, 2 significant figures, 2 significant figures. Okay, if you're calculating and using numbers which are 2 significant figures, then your calculated value should also be 2 significant figures. I forgot about the current here as well. This is also 2 significant figures. And so therefore you need to make sure that those match up. Okay. All right, guys, that's a nice short one. I was just checking to see if there's any more there. Please have a look and then carry on to the next question.